Okay, let's take a look at this price elasticity of demand problem. Now, here's the problem in front of you. The Postal Service of St. Vincent, an island in the West Indies, obtains a significant portion of its revenues from sales of stamps, special souvenir sheets, okay? The souvenir sheets usually contain several high-value St. Vincent stamps, okay? And they're designed and printed for the Postal Service by Imperial Printing, a stamp agency out of the United Kingdom. Now, the souvenir sheets cost the Postal Service 95 cents, and they're selling them for $6, and they ordinarily sell about 57,000 units. So to test the market, they want to introduce a sheet at $7, and when they did that, the sales dropped to 47,000. So you're asked to first calculate the contribution margin, okay? And this is pretty straightforward, right? If you look at my work down here, you can see how I filled in the answers above. The selling price at $6 was 57,000. That's given to us, $6 and 57,000. So we just multiply those two and we get the sales. The variable cost would be equal to the number of units times 95 cents, which was given to us right here. Okay, so then to calculate contribution margin, just take the sales less the variable cost. Now, we just copy this over and raise the selling price to $7 because that's what they did. And the units fell to 47,000, so the sales become 320. The new variable cost are 47,000 units times 95 cents. And if we subtract the variable cost from sales, as you can see I'm doing here, subtracting cell D21 from D20, you get 284,358. All right, so next we want to calculate the price elasticity of demand. Okay, now down here is the formula. The price elasticity of demand. We can calculate that by taking the natural log of 1 plus the percentage change in quantity sold divided by the natural log of 1 plus the percentage change in price. All right, so let's calculate the change in price here, right? So we went from $6 to $7, so the change was $1. Okay, change went up. Units went down from 57 to 47, so it fell by 10,000. Well, what's the percentage change? Well, you take the difference divided by the base. So the value of E18 is $1 divided by 6. It went up 0.166667, right? Or 16.67%, let's say. And if we calculate the change in the sales units, right, it dropped by 10,000 units from 57,000. We do that calculation, and we get a drop of 17.54%. All right, I'm showing some extra points just to show you that calculation really goes more than just a few decimal points. All right, but they're asking us to take the natural log of these. So if I move over to the next part of the function, we've got to add 1 to it. So now I'm just adding 1 to the percentage change, right? 1 plus the value to the cell to the left. All right, and then we're going to take the natural log of that. And in Excel, what you do is you enter equal ln and give it the cell. All right, let me just do that here. I'm going to say equal ln left paren. Now you guys know I like to come up here, call this up so you can see the function. It says, well, what number? That number. Okay, and then you can copy that down and you'd get the value for the next row or for the selling units. So now that we have that, we've got the numerator and the denominator, we can do the division. So we divide one by the other. Now I am rounding it to 4 decimal places. You can see I'm using the rounding function here. Okay, and I get a price elasticity of demand of negative 0.12514. Goes right there. Okay. Oh, they did ask, do you make more money at $6 or $7? Well, we can see we made more at 6. Okay, so now we've calculated the price elasticity of demand. Okay, then the next question they say is, what's the profit maximizing price we can calculate using what we know? And the profit maximizing price is equal to the price elasticity of demand divided by 1 plus the price elasticity of demand times the variable cost per unit. All right, so the numerator is negative 1.2514. That's our price elasticity of demand. The denominator is 1 plus that. So if we divide that, now we calculate the first coefficient, which is D36 divided by D37. So we've calculated what's in the parentheses. Then we have to multiply it by the 95-cent variable unit cost. That's right there. We do that, and we can then calculate the profit maximizing price. And we did that. We come up with 4.73. Okay? So given this information and our little test, it appears that 4.73 is the maximizing price. Now, look what they say. Rather than immediately dropping the price, it probably would make sense to drop the price a bit and observe to make sure that their one test is readily observable at other price points. Okay? This formula does assume that price elasticity of demand is constant, and that may be true, but it may not be true.